Hello students, let us continue the session on quadratic equations. We had completed exercise 4.1 in the previous session. We shall begin with exercise 4.2. First question, state whether the following quadratic equations have two distinct real roots. Justify your answer. There are 10 sub-questions. We shall solve each one of them. The basic concept used to solve this question is we will make use of discriminant, which is nothing but b square minus 4ac when the quadratic equation is of the type ax square plus bx plus c equal to 0. Let's solve one by one. Let me take up the first question. The given equation is x square minus 3x plus 4 equal to 0. We need to find out the discriminant value d equal to 4ac. Let's substitute. B value is negative 3 minus 4 times of a is 1, c is 4. We get it as 9 minus 16, which is equal to negative 7, which is less than 0. Whenever d is less than 0, we have no real roots. This implies the equation has no real roots. Let's take up question 2. 2x square plus x minus 1 equal to 0. In this case, what is the discriminant value? It is b square minus 4ac. Let's substitute. B is 1, so 1 square minus 4 times a is 2, c is negative 1. You'll be getting 1 plus 8, nothing but 9. D value we are getting greater than 0. Whenever D value is greater than 0, I can say that the equation has two distinct real roots. Let's take up the next one. Question 3. Two x square minus 6x plus 9 by 2 equal to 0. T value is b square, which is negative 6 square minus 4 times of a into c. This will get cancelled. We will be getting 36 minus 36, which is equal to 0. When d equal to 0, we know that the given equation has two real and equal roots. Now the fourth one. The equation is 3x square minus 4x plus 1 equal to 0. Here what will be the value of d? D is minus b square, which is minus 4 square minus 4 times of a into c. So it's positive 16 minus 12. We get it as positive 4. So d value is greater than 0. This implies that the equation has two distinct real roots. Let's look at question 5, we have x plus 4 whole square minus 8x equal to 0. This equation has to be further simplified and make it as a standard form. Then we have to make use of b square minus 4ac equal to d. Let me simplify this. This implies x square plus 16 plus 8x minus 8x equal to 0. Here the positive 8x and negative 8x will get cancelled. We get x square plus 16 equal to 0. This is the given equation. So what will be the value of discriminant, which is b square minus 4ac? Let's substitute. B square is 0 square minus 4ac. 4 into a value is 1, c value is 16. We get it as negative 64, which is less than 0. When discriminant value is less than 0, the equation has no real root. Next one, sixth one. Given equation is x minus root 2 whole square minus 2 times x plus 1 equal to 0. This implies x square, when we expand it, it becomes positive 2 minus 2 root 2x minus 2x minus 2 equal to 0. Here you observe this positive 2, negative 2 will get cancelled. We get the equation as x square. I can take this negative x as common, so I'll be getting 2 root 2 plus root 2 times x equal to 0. Now you apply the value discriminant formula. Substitute b square is, let me write everything in brackets. This is b square minus 4 into a is 1, c is 0. So this term will become 0. So only thing I need to do is expand this. It's a square of a number. So this negative, when it is squared, it becomes positive. So it is nothing but 2 root 2 plus root 2 whole square. I have neglected this negative now. Look at the value. Obviously this is greater than 0. So as d value is greater than 0, I can say the given equation has distinct real roots. Let's move on to question 7. We have given a root 2 x square minus 3 upon root 2 times x plus 1 upon root 2 equal to 0. Here we need to apply the formula d equal to b square minus 4ac. Substitute the value of b. We get d as negative 3 by root 2 whole square minus 4 times of root 2 times of 1 by root 2. We have root 2 getting cancelled. So the value of discriminant becomes 9 by 2 minus 4. Take LCM and find it out. We will be able to get 1 by 2. This 1 by 2 is a positive number, hence d value is greater than 0. Once the value of d is greater than 0, we can conclude that the given equation has two real and distinct roots. So I can write this implies the given equation has two real and distinct roots. Let's move on to the next one, question number 8. In the 8th question, the equation given is x times 1 minus x minus 2 equal to 0. This is also not in a standard form, so we need to multiply this x. We'll be able to get this. This implies x square minus x plus 2 equal to 0. I have multiplied throughout by -1. So let me find the value of d now. Using this formula, we get b square as -1 minus 4 times a is 1, c is 2. Now this is 1 minus 8, which is -7. This -7 is less than 0. This implies the given equation has no real roots. Next we have question 9. The 9th question is x plus 1 multiplied to x plus 2 equal to 0. Again, this is not in a standard format. Let's make that. So let me multiply x to these two terms. So I get x squared plus 2x plus 1 multiplied, we get x plus 2 equal to 0. This implies x squared plus 3x plus 4 equal to 0. So here the value of b square minus 4ac, let's find it out. We get it as 3 square minus 4 times of 1 into 4. So 9 minus 16 is a negative number. So d value is less than 0. Therefore, no real roots for this equation. Let's solve the last of question 10. We have x plus 1 multiplied to x minus 2 plus x equal to 0. Let me multiply these two terms to make it as a standard one. I get x square minus 2x plus x minus 2 plus x equal to 0. Here this x plus x becomes 2x and this negative 2x will get cancelled. The equation turns out to be x square minus 2 equal to 0. Apply the formula b square minus 4ac. B square value is 0. So 0 square minus 4 times 1 into minus 2, which is positive 8. So d value is greater than 0. This implies the given equation has two distinct real roots. This is how we solve the first question. Let's take up the second main question. The second main question is to write whether the following statements are true or false. Justify your answer. First one, every quadratic equation has exactly one root. No doubt it's a false statement because we have learned that a quadratic equation means it is having the highest power as 2. Therefore, there will be maximum two roots, two distinct roots. Let me take some example and show you. First, let me mention that this statement is a false statement. So let me consider an example. Consider say x square minus 4 equal to 0. We have x square equal to positive 4 x will be equal to plus or minus root 4, which is plus or minus 2. So positive 2 and negative 2 are distinct roots. So a quadratic equation will not be having exactly one root, it can have maximum 2 roots. So let's take up the second statement. Every quadratic equation has at least one real root. Is this statement true? Every quadratic equation has at least one real root. No, this statement is also false, because we have learned the discriminant, if it is less than 0, we will be having no real root. Let me give an example. Now let me consider, say, x square plus 1 equal to 0. This implies x square equal to negative 1. So x will be plus or minus root of minus 1. This particular number is no real. It's not a real number. Therefore, equation will have no real root in this case. Therefore, some quadratic equation will not be having a real root always. Let's take up the third statement. Every quadratic equation has at least 2 roots. For this also, I would like to discuss with an example. If I have x square minus 4x plus 4 equal to 0, this is nothing but x minus 2 whole square. When it is x minus 2 whole square, it is x minus 2 multiplied to x minus 2 equal to 0. So x is equal to 2 or 2. They are equal roots. So in this case, since they are equal root, I will say that it has got only one root. So this statement I may consider as false if you think in those lines. If you think that 2 is the only root, then this statement is false. If you think that both the roots are 2 and 2, then this statement is true. Alright, let's take up the fourth one. The fourth statement is every quadratic equation has at most 2 roots. This statement is true, because we have seen in the quadratic polynomial also maximum 2 roots are possible. Suppose if you consider, say, x square negative 5x positive 6 equal to 0, the roots are 2 and 3 respectively. So maximum 2 roots are there. In the previous example, we have seen x minus 2 whole square equal to 0. It was having only one root. So one root, maximum 2 roots. Or if you have a quadratic equation like x square plus 1 equal to 0, no real root. So 0 number of real roots, 1 number of real root, maximum 2 number of real roots. Therefore, the given statement is true. Have a look at statement 5. If the coefficient of x square and the constant term of quadratic equation have opposite signs, the quadratic equation has real roots. Is this statement true? Before judging whether it is a true or false, let me take a general form of quadratic equation ax square plus bx plus c equal to 0. They are given if the coefficient of x square and the constant both are opposite sign. If a and c have opposite sign, then what will be the product AC? Product AC will become less than 0. This implies the discriminant b square minus 4ac will become larger than 0. This implies when discriminant value is greater than 0, this implies the quadratic equation or the equation has real roots. So with this conclusion, I can say that the given statement is true. The last statement, sixth statement, if the coefficient of x square and the constant term have the same sign, and if the coefficient of x term is 0, then the quadratic equation has no real root. Is this statement true? Let me take again the standard form. They have given that a and c, the coefficient of x square and the constant, are of same sign, and b value is 0, then what is the value, discriminant value, b square minus 4ac? This will become 0 square minus 4 times ac, which will be negative 4ac, which is less than 0. When it is less than 0, the equation has no real roots. So in the given statement also they have mentioned that it has got no real roots. So this statement is also a true statement. Let us answer the third main question. The question is, a quadratic equation with integral coefficient has integral roots. Justify your answer. The answer is no. A quadratic equation with integral coefficient zero plus or minus 1 plus or minus 2 plus or minus 3 and so on can have its roots in fraction. Which is, that is, non-integer. So I can say that non-integral. Let me give an example so that you will understand. So 5x square plus 3x minus 8 equal to 0. If I take, all the coefficients are integers, positive 5, positive 3, negative 8, these are integers. Let's find out what will be their roots. Let me solve this by the method of splitting the middle term. The sum is positive 3 and the product is negative 40. It is possible with 8 and negative 5 combination. 8 plus minus 5 is positive 3. 8 into minus 5 is 40. So splitting middle term, we shall split the middle term as 8x and 5x minus 5x. So in these two terms there is x common. I'll be having 5x plus 8 minus 1 common, 5x plus 8 equal to 0. So we get 5x plus 8 multiplied to x minus 1 equal to 0. Therefore, the value of x is negative 8 by 5 or positive 1. Here, negative 8 by 5 is not an integer. So what you can say, given statement is not true. It's a false statement. Let's take up question 4. Does there exist a quadratic equation whose coefficients are rational but both of its roots are irrational. Justify your answer. We have quadratic equations wherein the coefficients are rational numbers and they will be having irrational roots. Let me give an example before justifying whether it's a true statement or false statement. The example is 2x square minus 3x minus 15 equal to 0. Just observe its discriminant value. B square is negative 3 square minus 4 times of A is 2. C is minus 15. We get it as positive 129. So roots are x is equal to plus or minus, x is equal to minus b, this is negative b, plus or minus root b square minus 4ac divided by 2a, or else I can also write as x is equal to negative b plus or minus root of d by 2a, where d is b square minus 4ac. Substitute this. So negative of negative 3 plus or minus root of 129 divided by 4. Here roots are irrational. Why it is irrational? Because root 129 is irrational. So the given statement is a true statement. Yes, a quadratic equation having the coefficient as a rational number can have irrational roots. Let's move on to the next one. Question 5. Does there exist a quadratic equation whose coefficients are all distinct irrationals but both the roots are rationals? For this also I would like to explain through an example wherein I'll consider irrational coefficient. So let me consider a complicated equation, 3 times of root 5 by 2 x square plus 5 by root 6 x minus 2 times of root 2 by 3 equal to 0. Here these are irrational coefficients. What is d value? B square, which is 5 by root 6 whole square, minus 4ac 4 times 3 root 5 sorry, I have made a mistake. I would have considered this root 3. So 3 root 3 by root 2 multiplied to negative 2 root 2 by root 3. So that these terms will get cancelled. It becomes a little easy to solve. So that's the only intention. D will become, this will be 25 by root 6 square is 6 plus, because minus of minus is plus, 8 3s are 24. We'll get it as 25 plus 144 by 6 by taking LCM. So the value of D obtained is 169 by 6. Let's use the formula. X is equal to minus b plus or minus root d by 2a. Let's use this formula. We'll have negative b, which is minus 5 by root 6 plus or minus root of 169 by 6 divided by 2a. 2 times 3 root 3 by root 2. Further simplify this, it is 5 by root 6 plus or minus square root of 169 is 13 upon root 6 divided by 6 root 3 divided by root 2. So x value we get it as, we have to take the LCM, it is minus 5 plus or minus 13 by root 6 multiplied to the reciprocal root 2 by 6 root 3. Here when you multiply this, it becomes root of 18. Root 6 into root 3 is root of 18. So minus 5 plus or minus 13 divided by 6 root 18, which is root 9 into root 2 into root 2. Root 2 cancel. 9 under root 9 is 3. 3 times 6 is 18. We get minus 5 plus or minus 13 by 18. Let me write it with a different color. Let me choose this color. This part I will write it here. So it's negative 5, negative 13 by 18, or negative 5 plus 13 by 18. So this is negative 1, or minus 5 plus 13 is how much? It is 8. 8 by 18 is 4 by 9. So look at these numbers. These numbers are rational numbers. So roots are rational when the coefficients were irrational. Therefore the given statement is true. There are 2 more questions left out. Let me take that. The question 6 is 0.2 a root of equation x square minus 0.4 equal to 0? Justify your answer. Suppose if 0.2 is a root, it must satisfy the equation x square minus 0.4 equal to 0. If you do that, 0.2 whole square minus 0.4, we get 0.04 minus 0.4. This is our left hand side. We get it as negative 0.36, which is not equal to 0, which is not equal to the right hand side. So LHS not equal to RHS. Therefore I can conclude that 0.2 is not a root of the given equation. Let's end this session with one more question. Question number 7. Question 7 is, if b equal to 0, c less than 0, is it true that the roots of x square plus bx plus c equal to 0 are numerically equal and opposite in sign? Justify. They are given if b is 0 and c is less than 0, we have to make use of that. The given equation is x square plus bx plus c equal to 0. Since they have given b is equal to 0, this implies x square plus c is equal to 0, or else x square is equal to negative c. So x value is plus or minus root of negative c. As c is less than 0, it becomes means a root of negative c becomes positive, because c value is negative. Negative of a negative is a positive number, therefore the real roots will be there. Therefore roots are real. Therefore the roots will be plus root of minus c or negative of root of minus c, since negative c is a positive number. Therefore the roots are real, equal and opposite in sign. They are given numerically equal, opposite in sign. So this statement is a true statement. That's all for today's session. We have completed exercise 4.2. Let's discuss 4.3 in our next session. Thank you.